The next chapter is K nearest neighbor classification method. We can use KNN, so this is also called KNN, for both classifying categorical target, or we can use it for interval target as well. And the method is based on calculating descriptive information from the data, and therefore this is called data driven as opposed to model driven. Like, for example, the regression model, we say that y is equal to beta sub 0 plus beta sub 1 times x sub 1 plus beta sub 2 times x sub 2 and so on. So we in the case of regression, we assume a model and then we try to develop estimates for that model. Whereas in KNN, and we will see a few other approaches similar to KNN, and these do not have any underlying model. So we do all the calculations from the data without making any assumptions about the relationship between the target and the other variables. So this is another way of characterizing these methods is non-parametric. So parametric here would mean that we make some assumptions about the model and we don't have such parametric assumptions, and therefore these are called non-parametric methods. The basic idea is to look for, so you have a new observation coming in and you want to make a classification for that observation, right? So now you fit that observation into the existing data and then see which other observations are closest to it. And then whatever class those close observations belong to, the nearby records, okay, then you classify the new case to that class. So now we have to figure out how do you measure nearness. So what does near mean anyway? Near here means similar to the predictor values of x sub 1 through x sub p, and that doesn't help very much when you say similar to. How do you measure similarity then? Well, let's look at one possible idea, and that is to compute what is called Euclidean distance. So suppose we have the new observation has these values u sub 1, u sub 2 up to u sub p. Okay, there are p predictors, right? So new observation comes in and these are the values of the new predictor. Now, so you go ahead and compute. So the distance between the new predictor and any given predictor observation, so you have x sub 1, this is the first, x sub 2 and through x sub p. So you compute this, and that's the distance between the new observation and the first observation in the data set. And then repeat this computation for the second row, the third row, and then so on. So this will give you the distance, Euclidean distance. So in 2 dimensions it will be a straight line distance, as we will see in just a minute. Okay. So then you sort the observations in increasing order, in ascending order. So this means that the one at the top has the least amount of distance between the new observation and the given observation. All right. So, and then you can look at maybe the first 3, the 3 closest, or 5 closest, or 6 closest. So and that's the reason we call this KNN. K here stands for how many closest observations you're going to look at. So if you say I'm going to look at 3, and then you look at the 3 closest observation and then see which class these 3 belong to, and then the one that has the most. Okay, so if there are 2 classes, if all 3 belong to 0, then you classify as 0. Or you conduct a poll, meaning what is the most frequent of the 3.